guys, in this video we're going to be looking at quadrilaterals and their properties, and we got a bunch here. So we're going to jump right on with defining, sketching, and detailing the properties of a quadrilateral. So a quadrilateral is a polygon with 4 sides and 4 vertices. So I'm going to sketch out here a quadrilateral ABC, and the only properties I'm going to list here are that the interior sum is 360 degrees. So we know a triangle is 180 and a quadrilateral is 360. So a parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay, so I'll sketch a parallelogram here. And let's talk about some properties of a parallelogram. So what are the properties of a parallelogram? We know that the opposite sides are parallel. That is a key property. We also know it inherits all the properties of quadrilateral, so the interior sum is 360. But there are a lot more properties here for a parallelogram. So we know that the opposite sides are also going to be congruent. So I can say, put my hash marks in there for congruent. I also know that the opposite angles are going to be congruent. So angle A is going to be congruent to angle C, and B is going to be congruent to angle D. All right. We also know that consecutive angles are going to be supplementary. So we have some parallel lines and transversals happening here, and we're getting some same side interior angles in this situation. So we know that angle A and B are going to be supplementary, and B and C. And we can also say angle C and D and A if we wanted. So consecutive means, angles that are right next to each other, like consecutive numbers would be 1, 2, 3. We also know that the diagonals of the parallelogram are going to bisect each other. So they're intersecting at each other's midpoint. So put some hashes on that. Let's box that in. And then that is parallelogram. So rectangle is going to inherit all the properties of a parallelogram and quadrilateral. So a rectangle is a parallelogram with 4 congruent angles. And if it's congruent, obviously that means that they have to be right angles. 360 divided by 4 is 90. So let's sketch out a rectangle for this. And let's list some properties here. We know that we're inheriting, just like I said, we're inheriting every property from the parallelogram. So that means opposite sides are parallel, congruent, opposite angles are congruent, consecutive angles are supplementary. It means that the diagonals are going to bisect each other. And a unique one here for rectangles that the diagonals are going to be congruent, which is not necessarily the same for just any parallelogram. So I can say that segment AC is congruent to segment BD. Let's see, let's throw some other things on here that we've inherited from parallelogram, as we discussed. Okay, I'm going to box that in. And let's take a look at a rhombus. So a rhombus is also a parallelogram that has all congruent sides. So it's going to inherit the properties of a parallelogram and quadrilateral. And so that's a lot of properties. And there is basically one new one that we're going to get out of the rhombus. So let's blow that up a little bit here. Let's get our properties. So we're going to inherit everything, as I just said, from parallelogram, and we know that all sides are congruent, so let's get that shown. We know that the diagonals are going to be perpendicular bisectors of each other. And the diagonals are also going to be angle bisectors of each vertex. And let's box that in. Okay, square is interesting because it's going to inherit all the properties of a parallelogram, rectangle, and rhombus. It's a parallelogram with 4 congruent sides and angles. So let's sketch that up. So rectangles give us the 90 degrees, and the rhombus gives us all the sides are congruent. So that's what we're inheriting here. We have diagonals that are going to be perpendicular bisectors, and also the length of the diagonals are going to be congruent. And sides are going to be parallel. Let's box that in. Okay, trapezoid is not a parallelogram. It is a quadrilateral with only one pair of parallel sides. This will still give us some interesting properties. We have one side that is parallel. We have bases. Top and bottom are called bases. We'll get to that in the next one. We know angles A plus B would be supplementary, and C plus D would be supplementary because of the same side interior angle theorem that we learn with parallel lines and transversals. Okay, I think that's all we got for trapezoid. Isosceles trapezoid is going to inherit all the properties of the trapezoid except an additional one that we're going to add, and that's the isosceles part. So we know isosceles triangles have two legs that are congruent. Well, isosceles trapezoid has two congruent legs as well. So here we go, we have our trapezoid ABCD. It's going to inherit everything from the regular trapezoid. But the legs are going to be congruent. So in this case right here, the legs are going to be side AB and side CD. Okay, those are the non-parallel sides. And then BC and AD are called bases. So the base angles are going to be identified. We have two sets of base angles. So we have the bottom base set, which is A and D. They're going to be congruent. And then the top base set are going to be congruent. So they're not all congruent to each other, but just the top and the bottom base angles. One other thing, and this is something we saw from rectangle, but the diagonals are going to be congruent. So segment AC is going to be congruent to segment BD. Last one is kite. So kite does not have any parallel sides, but it is a quadrilateral, so it inherited all those properties with two pairs of congruent and adjacent sides. So adjacent means next to each other. So let's make a kite. We'll call it ABCD. And let's list some properties here. So we have non-vertex and vertex angles in a kite. So where the two different length sides meet is the vertex angle, non-vertex angle, and where the two congruent sides meet is the vertex angle. So angle A and C are the vertex angle, and B and D are the non-vertex angles. So the non-vertex angles in a kite are congruent. And the diagonals of the kite are going to bisect the vertex angles, so they're angle bisectors. It's going to give us, two congruent triangles on that left side and right side. Okay, and the two diagonals are also going to form a perpendicular, and the non-vertex diagonal right here, BD, is going to get bisected by that vertical diagonal. So I got to put my 90-degree angle here on the diagonals to show that they are perpendicular. And I believe that's it. Let's just fix this up a little bit. And those are all of our properties. All right, guys. Hope that makes sense. See ya.